Hi everyone, I'm Eleni Pagkapoulou and I'm an engineering architect with Cisco. So let's start. So it's just going to be one slide for intro, don't worry. As you know, if you look throughout the network operation lifecycle, you can think of all processes as being broken up into a series of decisions and actions. And the primary focus of automation so far has been on automating the actions. And these are mostly tool-based. So you can have workflow tools, provisioning tools, and so on. However, with decisions, it's more knowledge-based. And that involves having a set of data and some sort of logic to operate on that data. And that logic is often convoluted and it's spread out over many different people at times. Which brings us to the main point here that at scale, the bottleneck for automation are the humans. So here, it's very difficult to scale your network engineers, and it's also quite costly if you even find them in the first place. So what we want to do here is automate the information gathering, so the data part, and be able to codify the knowledge and the reasoning as well to that. And that would enable us to make more decisions, better decisions, and faster decisions. So with Crosswork network automation, we're automating the complete life cycle of network automations. We're not going to walk through that right now, but the key point that we do want to make is that with AI, we can make this better. So there are a lot of things that we can do to improve all these different functional blocks. And one point here is that AI is not one thing. AI is a tool set, and as with all tool sets, it's very important to know what tool to use for what job. Like you're not going to use a drill when you must use a hammer, and so on. So here in this session, we're going to focus on the planning functional block as well as the optimization one. So for planning, what we're going to talk a lot about is how do we predict network behavior. So you know how your network is at any point in time, but you want to understand how it would be under different circumstances. So ask what if stuff. And then on top of that, knowing how the behavior would change, you want to be able to optimize and have AI-led design for that. And then looking at the optimization part, that would be during the operations, like given how things are, so you can't change so quickly your plans, but given the plans that you made, how do you adapt to the ever-changing conditions so that you can tune whatever KPIs you want to make better, right? So with that,
thanks, Eleni. My name is John Lahan. I'm the product manager for what we're calling Crosswork Planning, which we've introduced this week and launched this week at Cisco Live. If we go to the next slide, we won't spend too much time on the marketing. Let's just jump into the... So let's get to the basics. How should I plan my network? Well, first of all, we need to find out what's on the network, which we do with the tool. We go out and we collect using SNMP or PCE, and we figure out exactly what's on the network. Device-wise, we look at all the tunnels, we look at all the IGP metrics, and we gather all of that traffic information. And from there, that's when we realize exactly what's on the network. And we become, I keep saying this to our customers, we become the oracle of the network. So we understand exactly what's happening on the network. Now, from a planning perspective, how would I plan my network? These are the questions that all operations and planners grapple with on a daily basis. What happens if a link fails? What happens if I add a new link? If the traffic is growing, how do I monitor that? How do I plan for that correctly over time? And what is the optimal solution? And that's what we're going to talk about today, about how we figure all of this information out. Jump to the next slide. So what are the benefits for that? Well, we want to reduce costs. We want to improve, of course, the performance of the network, optimizing the network and increase efficiencies. But really, how are we going to do this? We're going to use AI-powered algorithms and optimization techniques. I'm going to hand it back to Eleni to kind of really jump into all of these techniques that we're going to use.
So algorithms and all of these techniques are great, but you need to be able to feed the right data to that. So of course, You need to be able to collect the data from your network. You need to be able to build the appropriate models, and more on that in a bit. So then you can take, if you will, a model instance of what you want to do, change it, do whatever hypotheticals, then get your output, and then implement it, and then rinse and repeat. So about the network modeling, like a lot of people kind of pass that by, but it's a very fundamental thing. So it's the foundation to any sort of predictive analysis that you do. So the network model is your view of the world. It's all that you know when you're doing any sort of analysis. And it's also very important to understand that there can be many different types of attributes and objects that you add. So, and you want control over who is able to set what. So you can have some attributes that you can think of them as input that can be set through the collection of model building, or can be set by users, or can even be set by optimization tools that go and set them. But you do want to have some other attributes that are derived that you externally cannot set. So let me give you an example. So let's say, like a very simple example. Let's say that you collect interface statistics, you collect the traffic measurements on an interface, and you model that, you capture that under as an interface attribute, and you have measured traffic. But then you can, if you want to have also measured traffic utilization as an attribute, you don't want that to be set externally as well, because that can be a conflict. So you need to be able to derive that based on the previous information. So having a clear schema, definitions, and those controls are very crucial. So a lot of times, like, we get the question, like, what should be in my network model? And the answer is very enlightening. It depends. So it depends on what you want to do. So for many use cases, it's perfectly fine just to have something very simplistic and have your nodes and your links and how they're connected, because you just care about some topological stuff or some inventory. So that's fine. But maybe if you want to do some analysis that also includes like segment routing policies or RSVP LSPs, like those need to be there. Those need to be part of the model. And then of course you have like more complicated cases where you want to look at not just the IP layer, maybe you want to look at optical as well. In which case you'd also want like optical nodes, optical links, optical circuits, and so on. So the richness of the models depends on what you want to do. And besides that, there are some like guiding principles that we have had, like in those model definitions. So we do want to abstract as much as possible, but not more. So really just to the degree that is needed. And we do want to have multi-vendor models that can be populated for different cases. And another key point here is extensibility. So to give the power and the ability to folks externally to be able to actually say, look, I need this attribute. It's not part of your official schema definitions, but I want to augment the model definitions myself and add that attribute. So that is very key, especially when, you know, adding slight variations of use cases and you want speed. So that part is important. And Crosswork planning model is very extensive, of course, extensible, multi-vendor, and so on. So
we're doing this a 1-2 punch. So this is the classic scenarios that we see, and this is how I present to a customer. You know, I talked about getting all the information, collecting it from the network. We build this knowledge base. This is a simplistic North American service provider thing that we put together years ago, and we still use to this day. But if you can see in the second diagram here, we fail a link, and we can tell if you have MPLS traffic routed tunnels, how it will reroute, how it will reroute on the network. And that's the same for segment routing or MPLS or RSVP TE. And we've got so many tools within Crosswork planning that are already pre-built. So this is kind of simple. Fail a circuit, what's going to happen? But actually we can sequentially fail every circuit on the entire network. Very useful for huge SPs, because to individually go through all of these circuits or nodes or whatever they decide to fail would take forever. So we have tools that will sequentially and programmatically go through every circuit and figure out what will happen in the event of a failure across your entire network. So operations teams love this tool, and this is one of what we call it sim analysis tool, or the worst case tool. But once you do that, and then in this last diagram, we give you a visual of it. By the way, we're doing this all in the abstract. We're not doing it on the production network. We give you a visualization of what would be the outcome in the worst case scenario. And the color coding, you may not be able to see it, it's kind of small on the slides, but you can tell at a glance where there's congestion or where there's potential congestion just by simple colors. Red, orange, yellow, and here we have purple to say, hey, you're actually dropping traffic on these networks in the event of this failure. So when you look at this, you go from an operation perspective, oh, we're going to fail here. So you can actually click on the interface, do a right click, and it will tell you what circuit will fail that will cause this congestion. And it will also give you recommendations on how to mitigate this problem. So we could do a couple of things. We can either optimize the network, and Elaine's going to talk about that in detail in a moment, but we can optimize all the circuits, or we can recommend, hey, you need to put in a new circuit, new hardware, but we'll make those recommendations for you. I think, yeah, so I spoke about the tools. So it's AI-powered operations and optimizing your network. Fortunately, this thing's blocking I can't see here, but among the tools we have segment routed, RSVP, path optimization, parameter optimization, metric optimization, and we also do capacity planning too. Key for customers to advance order, lease lines, advance order hardware. Like a couple of years ago, remember the inventory cycle, it was a big issue. You really needed to have your hardware orders in. So this helps you have these in advance planning done. Demand deduction, that's the secret sauce here. We actually look at all the traffic and we figure out where all the traffic is going on the network. We can do this in a number of ways, but we use mathematical algorithms to figure it out. Sometimes customers aren't exactly excited about that. They want to get net flow data, and we can do that too. So we can deploy net flow clients and gather the data that way. And that is, percentage terms, maybe 1 or 2% or even 3% more accurate than our demand deduction at times. What else is here? And then the optimization techniques include mathematical optimization and heuristics. And Elaine's going to talk about all of these mathematical equations now.
Yeah, so just zooming in a bit more, because this session was about not having too much fluff. I hope it's interesting to you guys. So there's many different classes of problems that can be addressed. So if you look just at segment routing and RSVP path optimization, we have a bunch of tools that do different things. So let's try to zoom in on a couple of those, not all, if it lets me. Great. So we're zooming into the segment routing T bandwidth optimization tool. And there's primary and secondary objectives as well as constraints. And all of these can be configured and controlled. So like the primary objective would be to drive down utilization on interfaces under a user-specified threshold. So somebody says, hey, I don't want more than 70% utilization on my interfaces. And in order to achieve that, I want to either create new segment routing LSPs that would divert traffic on different paths, or I want to reroute some of the existing ones. And maybe there's some secondary objectives like, hey, while I'm doing that, I don't want to just drive down utilization, but I want to maximize my available bandwidth so I have more buffer in the future. Or maybe I care about minimizing delay and so on. And there can also be additional constraints like, hey, I don't want to have latency exceeding X milliseconds. So even if it drives my utilization down, I don't want to do that because it costs too much in terms of latency. So you could do things like that. And then zooming in on another tool, like an RSVPT optimizer tool, it has not just primary, secondary, it also does have tertiary objectives. And to that, what I didn't mention before is, of course, you always have something that you really care about, but maybe you can achieve that in many different ways. So having that control over like what you're willing to trade off as a secondary or even tertiary objective, you can find better solutions. And here, what's interesting is that not all of your RSP LSPs are going to be the same. They're not going to be for the same reason that they exist. So you can have more control as to how those objectives are imposed based on the group of LSPs. So you can say, hey, these are the ones that, this group of LSPs that I really care to optimize based on, bandwidth constraints or delay constraints. But the others, like I put them someplace that I'd like them to stay there if possible. So the fit group. So only move them around if you must, but like I'd rather that they stay where they are. So there are things like that that are give users more power to control things. So on optimization techniques, so here we're just grouping it into two main groups, so mathematical optimization and heuristics. So with mathematical optimization, like most often, like you typically would have an optimization objective, like minimize a function, minimize, my costs, right? Or it can be maximization, it doesn't matter. And then you have a set of constraints. So things that you want to impose, like, hey, like I was saying before, I don't want my delay to exceed this much, or I don't want my utilization to be more than 70%. So you capture all of these objectives and constraints in a mathematical formulation. And then what this really does, I don't know if you're a visual person, like you can think of the variables as dimensions in your space, right? In multidimensional space. And then the constraints are kind of confining your feasible solution space. So then within that feasible solution space, you're able to search that space and find out of the feasible solutions which one best meets your optimization objective. So that's with mathematical optimization. Heuristics is more, I guess, what's more typical in a lot of cases where you just have some heuristic algorithms. You iterate over several things, if then else, loop back, go back. So it's more like an algorithmic approach, which may not have guarantees on optimality. And I think that's part of the decision, like the fun and frustration of figuring out what the best optimization technique to use and when, because there are questions like, do I really want the best solution that is possible? How long am I willing to wait for that? Like, what do you want to pay computationally? Like, what's the cost? So finding those trade-offs and that balance is what guides a lot of those decisions. And, you can make all the pretty math you want up in a mountain, but that it has to be grounded somewhere. So here, like you see at the bottom, we have the network simulation engine. So what you need to do is you need to be able to understand the network behavior. Like if you have many different ISIS levels, you have some constraints as to what paths can be followed. You can't just take any path you want, right? So we need to be able to ground that to how networks actually behave. So there's this back and forth between the formulations, optimizations, and of course the simulation engine behind that. So up until now, we're talking about planning and a lot of the crosswork planning capabilities that we have. And now we're going to zoom in a bit on optimization. So here, it's just one slide. So you can do all the wonderful, great planning that you want, but still, when you're operating things, there will be cases that you didn't plan for. And sometimes that can be, something like unexpected traffic patterns, or maybe you get like 3 fiber failures at the same time. You could have planned for that, but maybe you didn't want to because it's very low probability and very costly to be able to capacitate for that, right? So for such cases, you need some tooling that help you address those issues as they manifest. So here we're going to talk about local congestion mitigation, which, as its name suggests, unsurprisingly, it's about mitigating congestion, but in a local manner. So like first you have to detect where congestion is, and then you want to react as close to the congestion point as possible. You don't want to move traffic away from afar, right? And the mechanism to do that here in this tool is segment routing policies that you deploy locally, and then you're able to divert as little traffic as you must in order to drive down the congestion. So you don't want to, you want to have the least impact possible while meeting your objective of something like, hey, I don't want over 80% or whatever utilization. And that is done like in an automated manner. So it's not like we were saying before, where there's somebody that says, okay, what if this happened? Like it actually happened. You have to react and you have to do it now. So we have two flavors of how it can work. So here, with the human in the loop, then this can run all the time, monitor, and then make recommendations and say, hey, I detect a congestion here. In order to mitigate it, I'm proposing that you add these segment routing policies with this path like that. Is it okay? And then the user actually goes and says, yeah, I'm good with that. And then it goes ahead and provisions those segment routing OSPs. And then it keeps track of it over time. It figures out when they're no longer needed with some dampening, because you don't want to be ping-ponging between, adding and removing. And that's the summary for LCM, and we have a demo.
You have a demo if you want to see it, but I want to invite you to ask us any questions about the planning or the COE or the CNC. Anything that...
Who's kind of ideal customer and network for this?
It's really service providers mostly, and larger enterprises. But I really want to democratize it a little bit and invite smaller enterprises as well. So anything around above 30 riders, I think I would recommend a planning tool of some sort. So this could be a good tool for even medium-sized enterprise.
Is there a max number of nodes that you can have as part of the modeling?
There is. We're saying 6,000 today, and with potential to grow higher. But now, when we say maximum nodes, it's not just, it's multidimensional. We have to think about how many interfaces, how many tunnels, how many LSPs, etc. saying the same thing. But so it's multidimensional, but 6,000 is a good point to key off. 6,000 nodes. So are we showing the Crosswork planning one or the LCM?
Crosswork plan. Okay.
So this is going to go quickly. I'll try and talk through it. And so we have, you can see all our demands. And here we're seeing a map of Europe. We're looking at the interfaces here. Now I'm just going to do a test and fail a link between London and Paris. And you'll see what will happen. So in the event of a failure, we redirect over to Brussels, I think that is, or down. Now, so here we're going to do a sim analysis of the entire network. And it's all menu driven. So a new starter could do this. And basically, again, it's an abstraction of your network. So you're not impacting your production network. You're seeing what can happen. You get a report like this, and it will tell you how many interfaces exceed the utilization. And you also get a visualization. So this is the color visualization of the worst case traffic view here. Boy, this is really fast, right? Now we're doing capacity planning. Boom. So here we set the max we wanted is 75%. And again, you drive through the menus and you can run this job in the background. And then you can set a new plan file, which is doing here. And then it runs the test and it comes back and it tells you, hey, we recommend the following circuit upgrades. And it will give you a report, and you'll have time to read that report. It won't be like this in seconds. So, and here, the final tool we wanted to show you was metric optimization. So the traffic might be congested in certain areas of the network, and we can go in and look at the IGP metrics and suggest metric redos on the metrics and give you a report of exactly what metrics to change. And then here we have it here, the old metric on the left-hand side and the new metric on the right-hand side. So I'll be taking quiz questions, so quick, right? But the point is that all of these tools are available and they're menu driven. So you don't, even a new user can get on this application and just walk their way through this GUI interface. So we're pretty excited about the ease of use. Not excited about the speed of this, but the ease of use is pretty cool.
These tools chargeable, or are they available to the larger enterprise customers that you mentioned?
Yes, so really we kind of price on a node per node basis. So we sell, as the product manager, I'll sell to anyone. So small, medium, or large enterprises are service providers. Yes, it's definitely available, the short answer. Yeah. Any other questions, thoughts? We thought 25 minutes was too short. We thought, hey, we'll give us more time. The kind of questions I see a lot include, is it difficult to install? We've really made an effort to make this nice and easy to install, GUI driven. How do we do the collection? I said it earlier, but to repeat, we do SNMP, or we can use PCE, or we can even take the IGP databases, OSPF, link state database, and we can figure out the topology and build out the network. So it does take a while. I mean, it could take a couple of hours to build the entire network, especially if it's a large service provider network or a large enterprise. So there's a little bit of work involved, but we've tried to make it as easy as possible, and that you don't, that the customer themselves can actually do it. So that was the goal.
You mentioned deployment of the segment route policies. What mechanism is used to actually deploy those?
It's through the SRPC, the segment routing PC, so PSEP.
To make those predictions, like how much kind of data are you looking at, like weeks, months worth, or is this a snapshot?
So for it depends on the use case. So if you want to do planning and you want to say, okay, what capacity do I need to install for the next quarter? You would typically look at, a few months worth of data. Maybe you want to do some analysis and say like, hey, I care about the 95th percentile of what I've observed in the past month or something like that, and then plan based on it. If you want to do more like operationally reactive stuff, like the LCM, the local congestion mitigation that we did, we want to be really close to what you're observing at that particular point in time. So it's within minutes, like you want to see how it's changing. And an important thing with tracking changes is sometimes you don't want to be too reactive, because you're, what I said before, like the ping ponging. Like you want to have some dampening, some buffer. So observe, but think before you react. Yeah.
Now you brought up an interesting question. So when we collect the data, it's user configurable, so we can do it every 15 minutes, every half hour, or daily or weekly. So you build up a plan file. Those diagrams, we call them plan files. You build up an archive of data, so you can work on a plan file from 15 minutes ago or from 5 years ago, whichever way you want to do it. So, and again, you're abstracting from the network. It's not doing it on your production network. And one actually cool thing about that is if you have a new hire, the new hire can play around with this abstraction and figure out what would happen if I took out this node or whatever, and it won't impact the production network, but you'll see exactly what will happen on the network.
And it's a model, so you can do anything you want with it. Like, so you can have like one instance where you did something, and another one you can do a diff and say, what's the diff? And then keep that diff and then apply it, because maybe you have some plans that you want to do. You don't want to do everything yet again. So you keep that diff and then apply it to something that you've freshly collected, today. So it gives you that power, like to be able to model it like that and capture it like that.
So can you maybe like use it and start integrating it with like, let's say Terraform and like other automation sort of tools, where like before I'm going to make a change, I want to use the model to test out the stuff?
Yes, that's an excellent question. We do have, like in the Crosswork suite, we do have some like what we call the Crosswork Workflow Manager, which like it goes ahead and makes changes. So before making those changes, we actually have a POC where you can go and invoke that and say, hey, what would be the impact if I make that change, like as part of the pre-checks? And then you can say, yeah, you're good, go ahead.
And what if I want to integrate it like with my automation tool? So do you have the APIs? And is there support for Terraform? Like
For Terraform specifically, we haven't looked into it, but we have a rich set of APIs. So everything you saw from the GUI, we have the corresponding APIs. We have the lower level, what we call the RPC API, and then we have like a Pythonic wrapper on top of that. That's kind of easier to use. So you can integrate, and you can do, and a lot of folks like just write their own scripts because you don't want to be in front of. I don't want to be in front of a GUI. Maybe some other people do.
Okay, cool.
Just to add, is it made it open software, so for that purpose exactly. I haven't tested Terraform or Terraform uniquely, but we would expect it to work properly.